This is section 1.1, linear equations and rational equations. And we're going to begin with solving linear equations in one variable. So the steps are pretty straightforward. The first step is we're going to simplify both sides of the equations. How did you do that? How do you simplify both sides? You could use the distributive property to clear parentheses. You can combine like terms. You could also clear fractions and decimals by multiplying both sides of the equation by the least common denominator of all of the terms. Our next step would be to use the addition property of equality and collect the variable terms on one side of the equation. So that will allow us to solve for that variable and the constant term on the other. Then we will use our multiplication property. We will check our solutions, and then, of course, we will write our solution set. Let's jump right in with number 1. We have an equation. We have linear. X is just to the first power in this equation, and it is in just one variable. So here we have x plus, now we need to clear those parentheses by distributing the 4, and again distributing the 4 on the right-hand side of the equation to clear those parentheses. Now, if I want to, before I combine like terms or move anything, as you can see, I can subtract 4x from both sides, and then these will cancel, and then I will have x minus 20 equals negative 8. So now I'm going to add 20 to both sides, and I'm left with, whoops, I shouldn't have those equals on that left side, and I will have x is equal to 12. And 12 is our solution set. Looking at number 2, we have 2x, and of course we want to distribute that negative 3 and distribute the negative 5. Okay, so here we have 2x, let me use a different color, 2x minus 6x, and then look what we have on both sides here, constants that we can combine. So 2x minus 6x is a negative 4x, and we have minus 6. And let's take 1 minus 15, that's a negative 14 minus 20x. Now we want to add 20x to both sides, and we have 16x minus 6 equals negative 14. Now let's add 6 to both sides, and we end up with 16x equals a negative 8. And finally, dividing both sides by a positive 16, and we end up with x is equal to negative 8/16, which is negative 1/2. So what could we do with that? We could see if we can make this a little bit smaller. We could now say that our solution set is negative 1/2. Okay, let's look at number 3. Now here you can see that we do have a decimal. You can choose to do what you want with these. I think the first thing I'd like to do is go ahead and remove the parentheses and distribute that 0.2. And 0.2 times 5 is equal to 1. So we just have an x minus, and 0.2 times 8 is 1.6. So now I need to add 1.3 to both sides, And you can do this in any order that you want, but I usually move my constant first. And this is going to be a negative 0.3. I can just write it like that. And now we're going to subtract x from both sides, and that's a 1x. So a negative 1 and a positive 0.6 is a negative 0.4x. And as you can see, we're getting into some decimals here. Now, if they don't bother you, then that's just fine. And actually, this is supposed to be a negative, as you can see. Let me erase this and write it a little bit closer here. That was a minus, so that would be a negative 0.3. And then same thing, divide both sides by that constant that's in front of our variable. And we end up with x is equal to, the negatives will cancel each other out, and we end up with a 0.3 divided by a 0.4. And I'm going to show you a little something in our calculator. So let's see if we can bring it up here. And in our calculator, what we can always do is we can say 0.3 divided by 0.4. And we can press this math button and press frac, which is number 1. And it will give us the fraction. Now, this was a pretty easy one. And of course, you knew that that was 3/4. But I just wanted you to know that. And then, of course, 3 divided by 4 are 3/4. If you wanted decimal, you could also say 0.75. So it doesn't really matter. I'll just go ahead and use 3/4 as our solution. So I just wanted to show you that on the calculator. I think we should be able to put fractions, especially if they're complicated, in our calculator to help us along the way. In order to learn new concepts, those kind of things take a little bit longer. Okay, already, can you see? We have an x term and an x term together on the left-hand side. And so we want to combine those. So let's go ahead and do this. This would be a nice little practice. So what do we have here? We have 2/3 minus 5/6. You could press enter. I'll just go straight to math, frac. And you can see that that's a negative 1/6. So now we have actually combined those fractions on the left-hand side. So we have negative 1/6 x minus 3 equals 1/2 x minus 5. Let's go ahead and add 3 to both sides first. And as you can see, we have a negative 1/6 x equals 1/2 x minus 2. Now, as you can see here, we are going to subtract 1/2 x from both sides. So again, we have the opposite of 1/6. And now I'm going to subtract 1/2. Math, frac, and I have a negative 2/3 x equals a negative 2. So now I'm going to multiply both sides by a negative 3/2. And if you multiply those together, as you multiply your numerators together and your denominators together, and as you can see, your numerators and your denominator, and we can reduce those, and we get x equal to 3. So just having that calculator sometimes is really handy. Okay, let's talk about conditional equations, identities, and contradictions, okay? So it's pretty straightforward. A conditional equation is true for some values of the variable and false for other values. So that would be when you end up with, for example, if you would end up with maybe a solution set of 5. That's conditional. An identity is true for all variables in which the expressions in an equation are defined. So an identity would be if you're solving and you ended up with 7 equals 7. That's a true statement. So that's an identity. An example of a contradiction is if you're solving and you get 0 equals 1. Well, that's a false statement. So you know then that you have a contradiction. Let's go ahead and solve these. I will just be working away, and I can mention any important facts first. We do want to go ahead and distribute that 2 first before we distribute the outer 2. So we distributed this 2 first. And like I said, I will just be working away here, and I'm distributing the 2 and not having to mention every little thing. Combining like terms, we have a 28 and we have a negative 8x. And what do you notice? I have the same thing on both sides of my equation. So this is actually a true statement. It would also equal 0 equals 0 if you subtracted 28 and you added 8x from both sides. They would all cancel. So we end up with 0 equals 0, but you wouldn't even know that. Need to know that that was a true statement. So we do have an identity. And the solution set is all real numbers. Okay, let's look at number 6. And in number 6, again, we will go ahead and work on that inside 2 and distribute that 4. And then why don't we this time combine like terms before we distribute that 2? And now what do you notice? This is false. Those are not equal. How would I show that? Let's subtract 28 from both sides. And we end up with negative 8x equals 8x. Well, that's not true. If you want to go ahead and subtract, I can show you another way. 8x from both sides. We end up with negative 16x equals 0. That is false. So we have a contradiction. I don't want to put that on the same line because it is not a false contradiction. This is a false statement. So we have a contradiction. And actually, the solution set is the empty set. Actually, let me back up a minute. I don't know what I was doing. Here, we can divide both sides by a negative 16. I didn't realize that was multiplied. I apologize. And we end up with x is equal to 0. So we actually have a solution, and this is a conditional equation. I'm sorry about that. You see right here, conditional when we get just a value. Okay, let's look at number 7. We're going to do the same thing. We're going to remove those parentheses using distribution and then we will combine like terms. So we have 5x plus 26 equals 5x plus 23. This is what I thought was on the last problem, forgive me. And we remove those, and now we say 26 is equal to 23. Really? That is false. So therefore, we have a contradiction, and our solution set is the empty set. You could also use what we call the null set. Okay, so now let's go ahead and look at these rational equations, and how we solve these is that we are going to go ahead and first mention our restricted values. And as you can see, x cannot equal 0 here. And again, x cannot equal 0 since we cannot have a 0 in the denominator. So we will be restricting the values to avoid division by 0. Okay? So let's go ahead and look here that our first one here, we say x cannot equal 0. Okay? Let's go ahead and look at our restricted value for this problem here. If this denominator cannot be equal to 0, if we set it equal to 0, and we solve that for x, you can see x is equal to -3. So therefore, x cannot be -3. We do not want it. So x cannot equal -3 because -3 would make the denominator 0. Okay, so we put those restrictions out there pretty quick, and we can do them for the next in a minute. So step number 1 is to first find the LCD. So we talked about this LCD. We have a 4, a 2x, and an x. A 4 is a 2 times 2. At 2x is a 2 times x. And then we have that x. We don't have any shared between all three of them. None of these are in common. So we need all of them. A 2, a times a 2. These two are shared. So we have a 2 times a 2. And then we need, and we have this x that's shared between these two. So we have an x. We don't have to write it down twice. And here we have 4x is our LCD. So we need every denominator to be 4x. So how we do this in this course is we will multiply every term by that LCD. So it is true that you're going to take 4x times 9 over 4 minus 4x times 1 over 2x equals 4x times 4 over x. That's how we do this. And then we will cancel these 4's, cancel these x's, cancel these x's before we multiply. And here we have a 9x minus, and as you can see, we have a 4 divided by 2, which is a 2, equals 4 times 4, which is 16. So now let's go ahead and add 2 to both sides. And we come up with 9x equals 18. And we'll divide both sides by 9. And we end up with x is equal to 2. Now we are okay because we did not have 0. So x is equal to 2. Let's look at this next one. Our LCD is not obvious, so let's talk about this. Here, you can see that this denominator is 1. So, what we need to look at is this denominator is x plus 3, this denominator is 1, and this denominator is x plus 3. So the LCD is just x plus 3. And you guessed it, we're going to multiply each one of these terms by x plus 3. And what we have here and what we have left is an x plus 6 minus, and let's go ahead and distribute this, 2x plus 6 equals 3. We'll combine a 2x and a 1x, and this is nice. Our 6's cancel, equals 3. We'll divide both sides by a 3, and we come up with x is equal to 1. Now, oops, did I do that wrong? Minus 6x plus 6 minus 2x. Oh, that was a minus 6. So, okay. Right there is a minus. Okay. So we end up with I guess those two are canceling. And that's what happened. That's a negative 2x and a positive x. So we end up with a negative x is equal to 3. We'll divide both sides by a negative 1. And we end up with x is equal to negative 3. But this is our restricted value. X cannot equal negative 3, so we actually have no solution. And so there is our empty set. Okay, we'll go ahead and work number 10, and we'll have a separate video for the second half. So here you can see that we have an LCD that we need. I'll work on the LCD here. So we have y minus 1. We have a y squared plus 2y minus 3. And we have a y plus 3. So we do need to factor this one. So if we go ahead and factor that, you can see that we have y plus 3 and a y minus 1. So here we have it. Our LCD is going to be this right here, since all of those have those two factors in common. So we'll multiply every term by both of those. And you know what? We'll just write it one time on the outside. Let's first write this. And then we could go ahead and write this. And we probably don't have to write this as big as we did. So we're going to multiply everything by y minus 1 times y plus 3. And then y minus 1 times y plus 3. And as you can see, the y plus 3's cancel. And then when we distribute this here, you can see that what we have left, the y minus 1's are going to cancel, and we just have a y plus 3. Now, what do you notice here? All of those cancel, and we end up with just the y plus 1. And here we just have a y minus 1. So that really cleared that up really nicely. So we have 2y plus 4 equals y minus 1. we will subtract y from both sides. And we have y plus 4 equals a negative 1. And then we'll go ahead and subtract 4 from both sides. And as you can see, we come up with y equals negative 5. So let's talk about restricted values. Look at these denominators. What do you notice? We have a y minus 1 and we have a y plus 3. Setting those equal to 0, we cannot come up with 1 or negative 3 as a solution. But here we got negative 5 as a solution. So this worked out just fine. This is not a restricted value. Okay, so I will conclude this in a second video.